Hello viewers, today we are going to see about PN junction forward characteristics. So we have taken two diodes, one is germanium and the other one is silicon. So we are going to see the germanium graph. So this is 0.1, 0.2, 0.3, 0.4 like that. Say roughly 0.3, slightly above 0.3. The current starts increasing. That means the diode goes into conduction. Less than 0.3, the current is almost negligible. So we can say that the diode is in off condition. Similarly, if you say here silicon, here is roughly 0.7. The current is maybe 1.5 milliamps in this case. So this is the characteristic graph of germanium diode, and this one is the characteristic forward biased characteristics of the silicon diode. So these two are popular semiconductors, but nowadays 90% of the IC production is based on silicon only. Okay. Now we will see how the forward bias connection. So this is the symbol of the diode. Assume I have connected 1K. Suppose if I give this is variable voltage. So this is nothing but a PN junction diode. So there will be a depletion region, P-type material, N-type material. So to break this depletion region, we have to give the voltage. For example, if this is made up of germanium, means at least 0.3 volts should be there. So for silicon, it is 0.7. Assume this diode is made up of silicon diode. Now if the voltage is 0 volts, no current will flow through the circuit. So in this case 0. So slowly I am rising. Slowly a negligible current will flow, say for 1 volt, 2 volt, 3 volt like that. So 0.1 volt, 0.2 volt, 0.3 like that. So when it comes to 0.7 to 0.8, the current starts increasing. That means the diode itself, if at all it has to conduct for silicon diode, the voltage required here is 0.7 volts. Okay. So here if it is going to be, now if you give 0.1, it won't conduct. Won't conduct means this diode will act as an open circuit. No current will flow. That's the meaning. The current in the circuit is 0. 0 means approximately 0 milliamps. Now you are increasing to 0.2. Still the diode behaves like a open circuit. But once when you reach 0.6, 0.7 like that, 0.7 that, you can assume that the diode can be treated as a short circuit. Short circuit means it has start conducting. That's the meaning. But the diode itself will take 0.7. This diode itself will take 0.7 volts. So balance at the load, this will be 0 volts. So current, still there is no current. But when it goes to 1 volts, this will take, diode will take 0.7. Balance 0.3 will be here in the 1K. 0.3 volts. So now the current flowing through the circuit is 0.3 by 1K, which is 0.3 milliamps. Okay. So when you give it say 10 volts, say 10.7 volts, what will happen? Here the diode will take 0.7 to break the barrier, and remaining 10 volts will be here. So in this case, the current flowing in the circuit is 10 divided by 1K is 10 milliamps. So the important point what we have to keep in mind is to make the diode to conduct, in case of silicon, it needs 0.7 volts. In case of germanium, it needs 0.3 volts. So this is about PN junction forward bias characteristics. Thanks for watching. Nandri.